This is question 16, test 7, section 7. It's page 79. So it says the figure above shows the route of Diane's trip from her house to her job. Diane travels 16 miles from A to B, 15 miles from B to C, and 4 miles from C to D. If she were able to travel from A to D directly, how much shorter in miles would the trip be? Okay, so let's draw in that path from A to D. Okay. So now you have to think to yourself, how can I figure out what this total distance is? And so hopefully you'll see that you can extend this line here and create a right triangle here. And then that will enable you to use the Pythagorean theorem to solve for the length of AD. Okay, so I'm going to call this leg A and this leg B. Okay, so the Pythagorean theorem is a squared plus b squared equals c squared, and c is always the hypotenuse, so that's the value we're looking for. So our a value will be 16 plus 4, so 20 squared, plus our b value is 15 squared equals c squared. Okay, so 20 squared is 400, plus 15 squared is 225 equals c squared. So this gives us 625 equals c squared. Then we take the square root of each side. So that gives us that c is 25. So 25 is the length of this hypotenuse. And they're asking us how much shorter is this new route compared to the previous route. So we just have to add 16 plus 15 plus 4, which gives us 35 as the length of the original route. And then we just subtract the length of the new route to give us how much shorter this new route will be. So that's 10, which is choice C. And for this problem, I just want to briefly point out that this is a 3, 4, 5 special right triangle. So a lot of the right triangles that you'll see on the SAT will follow this pattern. So when this leg is 20 and this leg's 15, then you might see that 20 is 4 times 5, 15 is 3 times 5. So then you know that this hypotenuse is going to be 5 times 5 because this follows this common pattern with 5 as the hypotenuse. 5 always has to be the hypotenuse in this 3, 4, 5 triangle because the hypotenuse is always the longest side. These leg sides are interchangeable. And so often you'll see side lengths that are multiples of the 3, 4, 5 special triangle. So if you look out for that, it can save you some time. But the Pythagorean theorem is also really helpful, and you don't have to be able to recognize 3, 4, 5 triangles. It might save some time and help you get a higher score, though, so it's worth trying to look out for those.